Okay. Next on, we're going to actually have a look at cameras and how you can actually hack them yourself to do stuff better than the manufacturer did it for you. Stephen,
Yes.
up to you to explain everything.
Okay, thank you. So, as you can see from the slide, this is about CHDK. If you're wanting another talk, my name is Steve, and I'm a little bit of a geek. So, when you create a talk that says Introduction to CHDK, you've probably got around 3 types of people in the audience. You've got those who are looking for an introduction, an overview, a nice little simple way into the product, the package, the bundle of code. You're looking for those who know CHDK and are looking to pick faults with the presentation and basically tell me I'm rubbish. And you've got the third type of person who is just waiting for the next talk and just wanted to get a seat. So, okay, I've actually found out who they are. Jolly good. So, in this talk, it says introduction for a very good reason. I'm an idiot. I'm not very clever, so it will only be simple stuff. What it is, what it does, and how you can do things with it. There'll be a lot of case studies in here, things that other people have done that might inspire you to go away. Pretty much all of them are not possible with the original firmware. This camera, for example, is one of the ones I use. I've been using it on my travels this last week. I actually bought this from a second-hand shop in North London for £5. That probably equates to about 20 euros at the moment. 18, apparently. It's not a bad camera. For a point and shoot that you can put in your pocket, it's not awful. But the stuff that Canon put on it is not the best it could be. The hardware is capable of stuff that the actual software doesn't let you access. We'll come to some of those things later. So when you write your own firmware, you can do anything with it, within reason. If you'd like to follow along with the code, download it from some of the links there. If not, don't worry about it. The idea of this is not to quote the READMEs at you. If you want to know the exact command line to do something with it, the documentation is already on the web. There's no point in me sitting here reading out slides and telling you exactly what you can find out somewhere else. This is hopefully going to be slightly more interesting and be about the journey that I took through it, so you realize it's not all the roses and flowers that everyone says it could be. So, what is it? Bullet point thing. It is an open source firmware, and we'll come to how open it really is shortly. It's for the point and shoot cameras, this stuff, the cheap stuff. You can get quite expensive cameras now. There's a newish project, Magic something or other, if you've got the DSLRs. They're kind of complementary projects, I guess, in that. Magic Lantern, that's the puppy. The project is several years old, so it's reasonably stable, and it's a temporary upgrade. So if you're worried about, oh, my nice new camera could go kaboom, no, probably wouldn't. I'll come into that shortly. It's okay, we're not going to blow up any cameras today. So what does it do? Well, I said it augments the existing firmware. The firmware in the camera does bits that it needs to. It takes a picture. It sets the exposure. It sets the normal things you need. But that's not enough. I've met very few geeks that say, I've bought a piece of hardware, and it does everything I need, and I'm not going to take it apart and have a look at how it works. Everyone I know will take it apart and say, oh, I wonder if it could do this. I wonder if I just put this in here. What if I run this instead? There's always something else you could add. One of the things that's been added is scripting. Why on earth would you want to script a camera? Well, why not? The amount of money people are raking in from hyperlapse applications, why not just write your own with 3 lines of scripting code? Increases the control of existing parameters. This camera has a shutter speed, because it's the crap camera, it's the low end, the shutter speed on here goes up to maybe 1500 if you're lucky. Well, you can actually increase that because the hardware can do more. Well, this one is the 550. This is the PowerShot A550. The 560 would have cost an extra 50 quid more. It's the same body, it's the same lens. What's different? The firmware. So why buy the upgraded camera for the better firmware? Just buy the cheaper camera and upgrade your own firmware. Controllable elements such as grids, we'll come on to grids later. Depending on what sort of camera you do have, grids is just an overlay that appears on the screen. So it gives you an idea on where the thirds are within your frame. So, example of parameters, increasing the range of the parameters. you may find your camera has an exposure limit of 15 seconds. This one did. I put CHDK on it. My exposure is now up to 64 seconds, which means you can take a shot like this, which allows you to see the waves coming up, and because it's been taken over 64 seconds, it gives that mystic, ethereal kind of hippie Glastonbury kind of effect. Increase the shutter speed. There is a limit. There is a physical limit of the shutter speed, but the physical limit of the shutter speed is not the limit of the firmware. Canon nobbled it, so we unnobbled it. That's not a bad picture, really, considering it was actually taken on something not too dissimilar to that one. Exporting as RAW. Why wouldn't you want to export as RAW? If you're doing any serious manipulation of photography, you want to have a RAW option. Well, why bother? This is for high-end cameras, they say. Why would you have a cheap point and shoot and actually want the raw image to do clever manipulation? Well, just because I do. Why do I do anything? Well, because I can. If I want to do something with RAW, give me an option to export it as RAW. That's available. Why not? This, as it says, I like this feature. I'm not a good photographer. I have a couple of cameras. I've played around for a bit. But I have never liked the flash in any camera I've ever had. The built-in flash of every camera I have found to be awful. It turns everyone into zombies. That's because the flash is mounted very close to the lens and it's very bright. What you can actually do is say, I would rather this flash go at half brightness. No camera manufacturer is going to think to put a, would you like to control how much voltage goes to your flash gun option? But we can, so they did. I say they did. I didn't actually code that bit, obviously. And obviously, there's lots of examples. I thought I'd better put some pictures in it. It's a photography tool. There's got to be pictures. And this gives you an example of what you can do by manipulating the flash. Is it safe? Yes, it's a temporary upgrade. So when I switch on this camera, which I'm now going to do and watch it fall over. Hey, it's a live demo. They're meant to break, right? The firmware that's now running on here, you may be able to see the little red block coming up in the middle. That's telling you it's running the new firmware. But it's not installed onto the device. Even if you properly install it, it never overwrites what's in there. Similarly, if you, it is possible to break it, but you can't with this, because there is an internal flash inside the camera. It is possible to write information to that internal flash. However, it doesn't do that, because that could potentially brick the machine. So there is no code in the platform at all that writes to that flash to cause that potential break. And I put the link down here to camera failure suspected to be caused by this. It's generally not. It's generally an idiot who's done something wrong. There was a couple of cases 2 years ago with a particular type of camera, but there have been no reported issues in the last, well, since then, basically, of something that can be directly attributed to CHDK. Again, I'm not a liar. Your mileage may vary, yada, yada, yada. Is the camera you have compatible? Well, this one is, and the reason I bought this one was because it was compatible. I went into the shop, I had an SD card, I created a ver.rec file onto the memory card, you put it in the camera, you start the camera up, and on the screen it says, this is running firmware version 1.0C. You toddle off to the little website, and it says, yes, this version is compatible. At which point you buy the camera and go home. Quite a lot of cameras, especially the older Canon ones, the point and shoots, do support it. It's very well supported. There are hundreds and hundreds of cameras that support it because they're all using the same chipset. If you're building a camera, it takes a lot of effort to design all the bits of stuff that go in here. They're not going to spend a lot of time upgrading the physicality of the machine. They'll upgrade the lens. They may upgrade the form factor. But actually, the stuff that takes the pictures, checks for the exposure level, does the autofocus, doesn't change from one version to the next. So there are very, very minimal changes between each version. So you'll find there's actually quite a good compatibility. There's also tools. I use this old method of creating a file on the memory card and booting it up. You can actually just use all these tools now. It's a shame. I learned the hard way. Getting ready? Yep, download a binary, compile your own, or use this stick tool, which basically allows you to plug the camera in. This will have a look at it and go, oh yeah, sorry, get it the right way around. The stick is, you take a picture with the camera, you grab the JPEG, you stick it into stick. it looks at all the meta tags that are stored within that JPEG. It goes, oh, right, well, this JPEG was stored in this way. Therefore, it must be this camera. And if it's this camera, therefore, you need to go down this binary image. And it goes down and it downloads that binary image. All automatically. Again, I'm putting all the links up for those that can see the bottom and who want to follow along. If you want to compile your own, it's a cross-compilation process. Obviously, this is going to be an ARM chip, and you're probably not going to have an ARM chip on your desktop. If you are, you're lucky. The rest of us have to use cross-compilers. You can build your own cross-compilers. If you're really sadistic, I just download binary blobs and use them. Sorry, I'm pragmatic. And command line is basically the platform, which is the camera number, platform sub, the version of the particular firmware in your camera, and fear, which is just the format, the actual binary blob that comes out the other end. So the installation process, how do you get stuff running on a completely weird thing? You copy it to the card, and you start the camera. And that's it. It's not actually complex. Sorry, was I going to try to do something that's complex? I'm not going to tell you everything. It's not complex. I actually, I had this running inside half an hour. And that included the time to actually look up and do the downloads. There's two main ways of running the firmware, the CHDK firmware. One is you say, update firmware. But it doesn't actually update the firmware. What the camera has, it has a series of vectors. And it says, if you want to do the taking a photograph, go to this routine, and then that routine jumps off somewhere else, which is in the firmware that actually does the work. That's in RAM. All the firmware update does is says, oh, right, you want to update. OK, well, point these to the memory card RAM. Off you go. So everything is being run from that point of memory and not being written into the flash, which is why it's safe to do so. The other way is just to use the lock feature. On the SD cards, if I can get this out, you'll know that there's a little switch on the side that is a read-write switch. Now, if you switch that to read-only mode, the camera will see it's in read-only mode and load that firmware directly into its RAM. But, I hear you ask, but, never mind, tough crowd. But if I've put the memory card into read-only mode, how am I going to write any photographs back? Correct. Do you want to give the talk instead? You're better at this, I am. Yeah, the switch doesn't actually change the read-write of the card. It just tells the operating system at the other end, I'm in read-only mode, please don't write anything. Well, of course, if you're writing the firmware that goes on here, you say, oh, is that read-write switch on? And the little memory card goes, yes, it's read-only. And the code goes, ha, I don't care. And it will write the data out anyway, which is a nice little hack to just get it running. Everything is done in what they call alt mode. There's a button on these cameras which has got a printer on it. Now, I don't know how many people plug this directly into a printer without fixing it up first in GIMP. I refuse to have any pictures of me online that have not been fixed up by GIMP so they can get rid of the bad skin. But that button, completely unused, except in CHDK, which allows you to switch into the alternate mode where you get all these extra little features that we mentioned earlier. How do you know you're in the alternate mode? Because the interface is an open source product and it looks a bit pap. The two are not connected, but you know what I mean. This is an example of the beautiful interface you will see. All of the parameters which are there and the hardware gives you that the Canon firmware hides away, CHDK allows you to expose. So it comes with batteries and memory and a clock. The clock's quite useful. I could have done this with a few years ago. OK, mid-lecture activity. I'll go to this side, a little bit different. As I say, I don't take many pictures, but I like to frame them properly. I like to look at what's in frame, and if anyone's photobombing me, I want to wait till they're out of the way. Which means sometimes it can take a couple of minutes for me to take a photograph. However, sometimes the people that I'm with don't appreciate the effort that goes into taking a quick photograph. So when they say, you've been doing that for 10 minutes, I go, no, the camera on my reimposed firmware tells me I've only been doing it for 5 minutes. It was more useful than I thought it would be. It's also relative. And my relatives know about time. There was another joke in that, I'd forgotten it. Good. Yeah, running. What script are you running? You get a live histogram of what sort of lights, colors are available in that, are being shot in that image. So if you're going for a particular style of photograph, you've got this stuff. Exposure, internal settings. Oh, go and Google it. There's stacks of stuff. Scripting, this is one of the fun things. Well, I say, it's all fun. I'm trying to sell this. No, I'm not. Scripting is easy. It's great fun. All you need to do is load the script from the disk, which is just basically a text file. You start it. You have parameters here, which you can set up. This one is an HDR script. And then you press the button on the top of the camera, and it runs the script. So I should go back. I'll show you something. On the bottom here, we have a series of parameters, which are unique to that script. Coding the UI for that is dull and boring, so you don't need to. What it is there is a piece of metacode at the beginning of the script that says, please show me on the menu a series of parameters, which are, for example, exposure mode, steps, f-stops, and so on. The script then runs. And I'm sure for those who are reading ahead of me, that does mean basic. There's a basic interpreter inside there, and there's a Lua interpreter. So this is an example of the parameters. You just specify them. The user can use the existing UI, sets them up, and then you write a script. And that's an example of the basic script that just does your hyperlapse. It will take a number of shots over a period of time that you can then do something magical with. Hyperlapse, possibly. This is an example of a Lua script. Again, you've got this meta tag at the beginning, marked by these minus, minus, bracket, bracket. Parameters work exactly the same way. Script then works as Lua generally do. This one is an example. I think this is Walter's script. You set the camera up, you press the button, and it then takes different pictures from the same settings. But it does a version with the vivid mode, it does black and white mode and sepia all at once. So if you're not quite sure if this picture is going to be a mean and moody picture or a nice fun picture, you just run it through the script, and it takes all of them for you straight away, and you can work it out later, as opposed to going into GIMP and trying every set of settings to see which one looks the best.
The girl mode.
Oh, so
The girl mode.
the girl mode.
Yes.
Yes.
The girl.
Yeah.
Like girl.
I'm not going to, I think you can probably work out set property, a particular ID, a magic number, unfortunately, of what the property is and what the value is being set to. So 206 is shooting mode, 1 is vivid, 3 is black and white, and so on. The scripts also have stub functions, which allow you to call out to the rest of the firmware, so you can change the focus, determine whether the flash is ready, simulate the button, so you can say, click the button, which is marked as zoom in. And the clever stuff, there's a motion detection thing in there as well, if you feel like it. I'll show you a good example of that later. All these functions are available from BASIC and from Lua. A couple of minor exceptions, but for most of the things that you're likely to play with, they're there for both. This is, one of the main things is just to take lots of pictures with different settings. This is HDR, so for those that have seen it, you take multiple pictures at different exposure levels. So if you'll take this picture on the top right, it's a little bit blurred, unfortunately. It's a scene inside. So obviously the sunlight outside is going to be incredibly bright, and the camera settings for that is completely different to the darkness of the inside. Now, normally you'd have to take a picture that's roughly halfway in between and just accept the fact some bits will be overexposed, some bits will be underexposed. Well, if we could take multiple pictures at the same time by pressing the one button, and we can change the exposure through the script, we say, take a picture with this exposure and this one at the same time, feed them into GIMP, and generate one image from it. So you get quite a good dynamic range that way. Here are 2 other examples, both taken with a £5 camera. Quite vivid, quite impressive, even for me. Not mine pictures, by the way. They're Zone Battler's pictures. And I think Zone Battler is his real name, or hers. Good question. It takes them in rapid succession as quickly as the camera is able to. So as long as it's not a fast-moving object or you're a bit unsteady, you'll get that a good image, a good result. Yeah, if you want to do the taking at the same time and processing, you'd have to take it in RAW and then go and process it later. I think for most purposes, quick succession is good enough. This is also an HDR. It looks drawn, it isn't. That's actually a photograph. So you can use it for special effects. So grids. This was the first camera I had. I've got a Nikon, which is quite big and not expensive, but for a 500 quid camera, I was surprised it didn't have grids. These cheap things have grids. As I said earlier, it's an overlay that goes onto the display as you're about to take the picture. Why is this important? Well, they're useful. If you're trying to take a picture and compose it in a particular way, you can draw an overlay onto the screen to line things up. Now, the Canon cameras come with a set of grids that they think are useful. Now, there's always some other grids that you will probably find useful for yourself and the type of projects that you're involved in. There'll be a bonus point for anyone can work out what that is on the right-hand side that hasn't already Googled it. So they're generated with a very simple piece of script code. It says, draw a line here, draw an ellipse there. And this is an example of one, as you see. Draw an ellipse, draw a rectangle, draw a line. What is it? Well, if you look at the correctly oriented version on the bottom right, this is where you have to put your face and your eye level for a passport photograph in the UK. This is not standard in the camera, but it's kind of useful. So if you don't want to sit in one of those little booths like Superman and take your picture, and you can just set this grid up. As you see, it's a text file. It is programmable. What else can you do? Well, you can draw lots and lots of lines. I wrote this little tool because copying things onto the memory card, booting up the camera, is not a long process. But I hate that process of having to go here to there to there to actually try out a one-line change. So I wrote a very simple parser in HTML that you put in your grid, it then processes it and renders it up on the right-hand side. The bit I actually liked was this little bit on the right, convert text. You don't have a text option in the grid language, but you do have line. And pretty much every letter can be generated by drawing lots and lots of lines. So I created a line-based font, and I parse the text. I think we can all do that. And then I generate at XY coordinate that particular text as part of the grid. So the grid could actually have your name in it. Or you could do what I did and put this camera is stolen. Because only someone that steals my camera and knows how to control CHDK and knows how to switch grids off is able to switch that off. Which means if they try selling it and the grid is already on, it's going to come up in the shop saying this camera is stolen. Which is quite good, which means the only people that can steal this camera are sitting in this room. Okay, I'll get a picture of you all later for identification purposes. And it's quite useful. There is a size limit on these grids. I can't remember what it is. It's probably around 12, 16K, something like that. So you can't write a novel and store it on your screen. But it's enough to actually put messages up and frame other things. So it's quite a good fun thing to try. And it's so incredibly simple that even if you're not interested in recompiling the binaries, you can at least put your own grids in there. So a little bit about writing modules. Not going to go too depth, as I say, trying to do an introductory type of thing. But modules are boring, so let's write a game instead. Actually, we're not really going to write a game. Everyone does Doom for some reason. They always get a camera and they say, well, I'm going to put Doom on this. It's like, oh, come on. So we're not going to do that instead, and it's not really going to be a game, but it's got, it comes with Snake and Tetris and a couple of things like that. Nothing too painful. To write it, it's simple. All you need is just grab the source tree, build it with the cross compiler. I always recommend doing the building thing from source, because if you do decide you just want to change Snake, or you can't play Snake, it's a bit difficult, and you want to change the score plus equals 10 to score plus equals 100, at least if you've got the compile chain running, you can improve the game that way. Take the source code to Snake. It's there. It's only one file. Very, very simple. Change any reference to the word Snake. Put in whatever game you're trying to write, and off you go. All done. There are two structures you need to worry about, the GUI handler and the module handler. This just says, when you start Snake, This is the function you call to draw it. And by the function you call, I mean the camera will call that method to say, now draw your screen. As you can probably tell, GUI mode Mandelbrot, you probably know what example's coming next. The main problem that I have with all this stuff is the fact that the UI changes between these cameras. And while the UI is not something we worry about, we've got our own, the colors used in the UI will change. So if you're trying to make yourself a nice little Mario clone or something on here, which you can do, you'll find that the colors will be completely messed up if you try using a different camera. There are a few colors which are predefined, but not all of them. So if you are trying to do the whole mist or something like that, you are going to have some problems. So you do need to keep it simple or just use black and white. The methods for drawing are those you'll find them, I think, in GUI.c. All simple. It does have a font inside the camera, so you can just say draw char. But you've got draw pixel, and once you can draw an individual pixel at an arbitrary position in an arbitrary color, you can then do anything else from that. If you're going to be polite, use the camera screen width and camera screen height. I know the resolution of this camera, but if I take the same code and run it somewhere else, it will look stupid. So it's always recommended you try and be nice and adapt your code to work with any screen size, which is easier said than done. Couple of methods to get the keyboard information. Yes, it's called keyboard, even though this does not look like a keyboard. And you can get the jog wheel as well as the thing says. The difference between clicked and pressed, if I remember the right way round, it says during the last frame, did the button go from up to down? And pressed is like, is the button down, generally speaking? Both of which have their own uses. And of course, once you can read from the camera input and you can write an arbitrary dot, you can write a Mandelbrot set generator. This is my go-to project. Any new device I ever get or any new platform I'm learning, I will write a Mandelbrot set generator. When I was learning JavaScript, I wrote a JavaScript Mandelbrot set generator because I needed to learn it. So I might actually be able to, although actually no one will be able to see it unless you're in the front row. So maybe we'll just skip it, but yeah, you're not going to be able to see that. Okay, but trust me, it's you know, this is the after I'd written it first time round. It has zoom capabilities. You use the, there we go, I'll point it out. Use the buttons here, the little D-pad, left, right, up and down. You scroll around, there's a cursor, and you press the middle button, and it zooms in on that for you. It takes about a second and a half to render one of those on one of those. Not the fastest thing in the world, but it's proof that it works, and it's always that good little thing, because it's so simple. And you know, you've written one Mandelbrot set generator, you've written them all. If something goes wrong, you pretty much know what has gone wrong. It's not the Mandelbrot code, it's your code with CHDK. So if you've got one constant in the whole thing, which is how to write Mandelbrots, the rest of the process is comparatively simple. Unfortunately, not all code is perfect. So how do you debug on a thing like this? Well, there's an LED here, and you can turn the LED on and off by writing to a particular memory address. So as you go through the code, you turn the light on and turn the light off. Light goes on, light goes off. And you count the number of times the light goes on and light goes off, and you know how far through your code it's got. Of course, that's a bit of a pain. So it's actually easier just to make the thing crash in certain locations and then look at the ROM log. It's the same as doing any kind of GCC work. You get a map and it will say at this memory location, you've got this method. At this memory location, it's this method. When the thing crashes, the ROM log will say, I crashed at this memory address. And you go, oh, that memory address is in that method. And if you just dereference a null pointer or something like that, you'll be able to say, oh, yeah, that's the method that's barfing. There's show camera log printfs and log printfs to throw it out. You can write to the SD card if you want to have a more explicit log if it's a very complex thing. Another way of doing it is this thing. I have no idea if this is still work. This is another one of my work in progress things. I thought, this is getting a bit painful. So I actually wrote a wrapper. So it's a complete null driver, basically. I know what methods the camera uses to draw a pixel, or draw a line, or draw a rectangle. So I rewrote them to call SDL, which is the simple direct media layer. I then wrote another little wrapper that says, if the camera code ever tries to say, what's the screen size? Or if the camera code says, what's on the memory card? I rewrote those methods to work in Linux directly so I could compile the CHDK code natively. Therefore, I can use GDB, and the debugging's a little bit simpler. It's a work in progress. It does very little at the moment, but it got me through a couple of sticky things when I was playing. And the code is awful, by the way. And it's not yet on GitHub, because I only did a version of it last week. It's that new. So if you download it, don't harass me. It's still pretty ropey. And all you do is you just say, create myself an SDL window through the abstracted dagger init, and then call GUI mad.what init, which is the same method that the camera would call when it starts to initiate your particular module. So let's look at some uses for this stuff, because this is the bit where I can get more sort of dynamic and run around a bit. Because at the end of the day, you're taking pictures. What sort of pictures are you taking? What sort of clever things can you now do? Well, if you can detect motion, then why bother sitting there waiting for that flash of lightning, that inspirational moment where it can literally take the picture when it notices something's changed? It's obvious, but it's not provided by default. So there's some code in there with a full set of parameters, how much of the scene changes to be considered motion. Across what sort of dynamic light range? If you happen to be at night, for example, you can say any amount of light that appears during the nighttime scene is a flash of lightning. Just take a picture. And it's not a bad picture considering the sort of parameters you're going to be using. So if you don't want the computer to decide for you, the CHDK, you can actually do it manually. Shutter release cables are usually 20 quid. Anyone that's had to buy Apple accessories will know the cost of cable normally, cable from Apple, and the price in between. Same is true with cameras. The shutter release for a bog standard camera technically has nothing more than a switch and a battery in it. Fortunately, it's all branded and all that kind of stuff, so it's expensive. Well, CHDK has a little option on there that says, if you connect a battery and a switch to the USB port, I will actually trigger the shooting mechanism when you press the switch. And it doesn't need to be a physical switch. It could be a thermistor that says, I'll take photographs when it starts getting hot. Take pictures when it gets cold. Take pictures when there's light. Put an Arduino in the middle. Says Arduino will do something, and the Arduino control when the picture's taken. I like taking pictures when it's hot. I did a thing. OK, mid-lecture activity. It's not actually CHDK, though, so it's a slide sheet. I often wondered what happens inside bread machines when you make bread. So I took a webcam, I taped it inside the bread machine, and I switched it on. And I have a very nice time-lapse picture of bread being baked, and the webcam bursting into flames when it got a bit too hot. You could do the same thing with one of these if you don't mind destroying your camera. I figured it was a 5 quid Microsoft webcam, and I didn't really miss it, so it was worthwhile. Or you could build yourself a bullet time rig. So if you don't happen to have a switch and a battery lying around, but you probably do have 60 different cameras, as I'm sure we all have somewhere, then there is no reason why you can't take that switch mechanism, hook it up to all those cameras, put them in a nice big hemisphere, and then with one button, trigger all of them at the same time. So you don't have 60 cameras lying around. OK, let's find another example then. What about 6? This guy has set them up. I don't know if he 3D printed these bits of plastic or not. Just 6 bog standard cameras mounted around in a circle, or hemisphere really, triggered to take an image at the same time. What's important about that? Well, you can build nice little panoramas. Because as we pointed out earlier, the picture's not taken at the same time when you do the scripts. It's one picture after another. How do you do multitasking on a single tasking machine? You have several of them. This is the best way to make Windows a multitasking operating system. Buy 2 Windows installs and run 2 different programs. Here, the guy is taking the picture at exactly the same time on 6 different cameras, running an HDR script to try and get this real depth of image, this real vibrance on color. And it comes off pretty well. No, you don't have 6 cameras to spare to make that. OK, let's try and find something else then. What about tying it to a kite? If you've got a kite, tie the camera to the bottom of the kite, run a script that will either say take it every second, every few seconds, when it gets light enough, put an altimeter in there and just say, well, when I get this high, trigger that little push button circuitry to make an image, and you take pictures like this. All that. This guy is Walter. He's very smart, very lovely man. I don't know where the camera is. Walter, if you're watching this on stream, hello. And you can still see him here. That's Walter. And that's the camera, the line going up to the kite. Still visible. No, you don't have a kite handy. OK, let's try something else that we've probably all got hanging around the house. What about a weather balloon, a bucket of helium, and the willingness to put a camera and a phone together and send it up into the atmosphere? For $148, some guys from the States sent their camera up, and it was basically the model down from this, up 93,000 feet. They stuck an 8 gigabyte memory card in it. They took pictures every few, I think it was about 30 seconds or so, strapped it to a helium balloon, and if you go on eBay, you can actually get them, not that expensively. Yes, I checked. I then sort of put my credit card away because I knew I was going to buy it. Get yourself a helium canister. All good joke shops have these. They're used for blowing up the balloons and making voices go really funny. GPS phone on there. This is primarily so you can find it again. If you are sending up your camera in a balloon, I'm pretty sure there will be at least non-zero wind between here and 90,000 feet. So it will probably blow off course a bit. So you need the GPS to say, oh, I'm at this location. Send a text message to my guy on the ground so they know where to go and pick up the camera. And again, you should put it in a nice box. Don't put name or address on it, because if it does fall on someone's greenhouse, you don't want to go and retrieve it. There are various legal things that you have to do. I neither know nor care about any of them. The main thing is I won't do it at home because I live near an airport. And if you start doing that near an airport, the civil aviation authorities and people like that will come and have a word. But if you can go out a little bit into fields and that, you can probably get away with it. And that's not a bad image for a crap camera. So if you don't happen to have 50-odd cameras to make a bullet time effect, or you don't have a kite, then at least build a balloon and send it up into space. So basically, love is, actually, no, love's not all you need. CHDK is all you need. And you can do lots of clever, funny, and weird things. And if there's any questions I'm smart enough to answer, I'll have a go at them now, assuming there's time left. There is time, OK. I wasn't keeping a track, so.
Is it possible to have the camera connected to a computer and get the images at the same time they're taken?
I believe so. I've not tried it. At that point, you have turned it into a webcam, I guess. But it would, it would be good, and I think it is possible. It's not one of the ones I've tried. Unfortunately, that's one for the README checks. Oh, yes.
If you're doing image detection or motion detection, how fast is it?
Sorry, how fast is the motion detection is the question, yes? The motion detection will vary depending on what it is you're detecting. If you're saying to it, I want to detect this specific amount of motion, then it's got to go through a lot more cycles to actually get that. But most of the time, you're looking at tenths of seconds, usually quicker, which is good. That's how we managed to get the lightning shot. Between that lightning happening and the photograph being taken, if it's any longer, you're going to miss it. So it is probably around that 50th of a second for most cases. But good question. Yes? I might need to calm. There's some chairs in the way. I'll repeat the question when I get down the front.
Can scripts access pixels of the image to read and write?
Ah, brilliant question. Right, the question is, can the scripts read the pixels of the photo you're about to take? And the answer is, if you have a fiddle, yes, you can. And but the time that it would take would probably be prohibitive, because the script is running through its own little scripting language. So it says, get me the pixel. It's like, OK, I've got the pixel. Now here's the pixel back, at which point too much time has elapsed to do too much useful things with it. The motion detection code that's running on here is actually a module. So it's already written in C natively. But it's a very good question, because there's some other functionality on here which I didn't cover. And you know when someone says, oh, that's a really good question, what they actually mean is, I forgot to tell you this before, and you've just reminded me I messed up. one of the features you have on here is Zebra. And what it does is it's a part of a module that will read the pixels from the display. It will say, oh, this bit's overexposed, this bit's underexposed. You probably need to fix it, either by reframing the image or and it's called Zebra because when you look at it, there's big white and black lines going through it to saying this bit of the image will be problematic. So for most useful things like that, you're probably best going into C and building it that way around.
The RDR images, are they assembled together or do I need them to assemble in an extra step on the PC?
Yep, good. Again, another good question, which also means I forgot to do this bit as well. The question is, do you need to assemble the image outside of the camera or does the camera assemble them for you? The answer is you assemble them outside of the camera. There are so many options of parameters and tweaks that you would potentially want to do. If you did write something into the camera to say combine them automatically, which is not that hard to do in reality, it's like, well, why? If it gets even slightly wrong, your image isn't going to look good. So why try and put an interface on the camera that controls all the parameters when you might as well just say, I'll export the images, I'll process it later in GIMP, because that's got all the tools implemented properly. Sorry, there's one behind first, and then what's you? You're in the queue.
Are you aware of any other brands, camera brands, where these kinds of hacks might work? Or why did you choose Canon?
Okay. The question is, are there any other brands of camera where this sort of thing works? And the answer is occasionally. Canon cameras, just for some quirk of fate, happen to get a project behind them and got some sort of a number of people who were interested. There was a critical mass of people who said, let's build it. And because most of them are using the Digic chipsets and people knew how they worked, they just said, right, well, let's just stick with this, which is why that one code base works with 200, 300 cameras. People who have also done this on other cameras have done so in a more isolated case. They said, I've got this camera, wouldn't it be good to run Doom on this camera? And they'd go and they'd work out how Doom would be written on that camera, but not made it more generic. Because this code is pretty generic. Even the code for write pixel varies between cameras. So it branches off. You call one method, it then takes a look, and it does something else. So there isn't, for example, a Nikon HackDK. I don't know what the origin of why they decided to pick on this particular camera. It might just have been a few people had it. They found they could hack it. So if you can, why shouldn't you? And it just snowballed from there. We can now pop the stack and go to the next in the queue and mix the metaphors.
When the camera is a bit old, usually they don't accept the new SD card standard, but only the old one. And is it possible to get rid of this limit?
The correct answer is I have no idea. So I could lie and try and make myself sound smart. I don't actually know. I know that these ones didn't used to be able to handle big memory, but I know you can put 8 gigs in this and not worry. So I can't say for sure that you could put in a terabyte card or something like that and it'd be fine. But it'd be an interesting thing to have a look at. If I do this talk next year, I'll include that in the slides.
Is there any sort of official firmware update that's used by Canon that exposes on speed cards?
Are you asking about incorporating this HDK into from Canon or?
You've worked out how to put software onto the camera.
Yes.
Can Canon do that officially with firmware upgrades?
Okay, so the question is, do Canon do firmware upgrades themselves in a similar way? And the answer is yes, they do, but incredibly infrequently. This camera has not had a firmware update since it was released, or rather a month after its release, which is not surprising. If you're building a piece of hardware and you're shipping out of the factory and it doesn't work, you probably shouldn't be shipping it. And it wouldn't be the same way that we put it on here, which is a temporary solution. They would actually rewrite that flash inside the camera. So taking extra actions, sorry? Mm-hmm. Yes. Okay, so the question, I'm going to try and get it down to something I can answer, is are you able to add functionality such as zoom in on a particular area where you're actually focusing on as far as interest of the camera goes. And yes, you can. That's a simple script thing again. So you can say in your example, this isn't a touch-sensitive thing, unfortunately, but you could use the D-pad, and you can say, in this script, I will pick up where the cursor is, and then when you press the button, that will then call the press zoom in button, which is the script command which just says click, and then the name of the button you pretend to click, and it will then go through its process of zooming in, and then you take the picture from that script. So you would be able to play with it in that way. One over on the right. So can the camera communicate over USB? I believe it can. I have not tried it. It would make sense for it to be able to do so. You wouldn't, as far as I know, you won't be able to do it through the scripts. The scripts don't have any of that kind of stuff in, but the camera itself should be able to access that. I don't know what you'd use as a terminal program on the other end. You know, might be able to access it as just a memory device, maybe. So there's obviously no more time. So my link to all of this stuff is from that one. I write a diary that's there. If you want to know what I think about the audience, you can go there later. And that's all me done.